Okay, so the next thing we're going to be talking about is motion diagrams. Motion diagrams. Okay, so to really set up this scenario, let's imagine that we have a car. A car that I will attempt to draw out. So we have a car with windows and doors. So we have a car, and we see that this car is performing straight line motion on this road. All right, so car, one second. Car is moving. Car is moving straight line. Right, so this car is moving straight line. And let's say we happen to take a video. We take a video of this car in straight line motion. So let's say exactly from this side where we're looking at the side of the car, we take a video of the car traveling from this side of the road to this side of the road, right? So we just take a video. For those of you who are not really entirely sure what a video is and how a video is created, oh, I just realized that I kind of spelled the word video. You know what? It's fine. This is videos, not video, not videos. So this is videos, and we take a video. Well, we take a video, right? Take a video. So let's say we take a video. As I was saying, a video is not really how we interpret real life. In real life, when we watch a car go from this star to this star, we are physically seeing every single point in which the car is going. But when we take a video, cameras don't really have the computational capacity to capture every single moment throughout this path that the car is at. So videos are technically really fast pictures taken together and combined to make it look like one continuous motion. So basically, if you've heard of a camera that's 30 frames per second or a camera that's 60 frames per second, when we talk about frames per second, we're talking about within 1 second, this camera is going to take 30 really quick pictures of this car, and the next second it's going to take another 30 quick pictures. So after a while, if we take like a 10-second video, we're going to have 300 pictures. And we, stitch those 300 pictures together and play them continuously. It kind of looks like the car is actually traveling. So it kind of tricks our eyes a little bit. We're actually looking at a series of pictures, but in our eyes, it looks like that this car in this video is actually traveling. So I brought that up because it's important that we talk about frames. So as I said, a frame is one of those pictures. So when we talk about, like I said, 30 frames per second, we're taking 30 of those quick pictures per second. So each of those quick pictures is called a frame. And an important thing about frames is that each frame is an equal interval or has an equal interval of time in between them, right? So when we take a video, each frame is going to be an equal amount of time in between each other. Our cameras are not going to take a quick picture at 0.1 seconds and then 0.3 seconds and then 0.5 seconds. That's not equal. Oh, no, it is 0.1, then 0.3, then 0.4, right? So that's a 0.2 seconds for the first, then 0.2 seconds for the second. So those aren't really equal intervals of time. Our cameras are video capturing devices will take, a picture at 0.1 seconds and a picture at 0.2 seconds and a picture at 0.3. You see each of those times increases by an interval of 0.1 seconds. So when we talk about frames, we always talk about frames that are equal intervals of time apart. We won't be talking about frame 1 and frame 2 having a distance amount of 5 seconds apart, then frame 2 and frame 3 having 10 seconds apart. That doesn't make any sense. That really won't help us understand the motion. So in speaking of frames, let's just say that one of these days we're looking at this video of this car and we want to break it down. We want to break it down into 3 frames, okay? So we're going to draw our first frame. So if we look at our first frame, or that first quick picture we take, it's just going to look like a car that is traveling. So let's say this is the road. Let me copy and paste this car to use for the rest of this example. Let me just capture that really quickly. All right, so we have this car, right? So let's say at the beginning, this car is over here, right? So that's where the car is at the beginning. So that's the first frame. I labeled it frame 1. That's the first frame. So at the beginning of the video, this car is on this side of the road at this point, at this star. Now let's draw the second frame we decide to look at. So that for that second frame, it's going to be the exact same road length, except this time, let's say the car happens to be in the middle. So we wait a specific amount of time, and our second frame shows that the car is in the middle at this point. So this is pretty simple. We have a first frame where it's at the beginning and a second frame where it's at the middle. Now let's look at the last frame we're going to analyze and let it be the third frame. So for the third frame, this the same exact road, but this time the car is at the end, right? So now this is kind of cool. We have an outline basically of this car's motion. We have it when it's at the beginning, when it's in the middle, and when it's at the end. So you can see this kind of describes the car's motion as it's traveling across the straight line from this star to this star. We can see it has at the beginning, it goes to the middle, then it goes to the end. So we kind of broke apart this car's motion into 3 separate frames. So this is what we call, frames. Like I said, I've been saying frames, frames. So each of these is a specific frame. But when we talk about motion diagrams, we don't like to really analyze things. We don't like to analyze movement as separate frames. We like to put it all together. So let me draw a bracket. So we take each of these frames, right? And we put them together. And we don't put them together time-wise. We put them together, we literally overlap them on top of each other. So let's say that this is that same road. This road over here is the same as this road over here, all right? So those are the same roads, just to point that out. So now if we put them together, it'll look something like this. So we have that first frame, frame number 1, right? It matches with this number 1 over here, frame number 1, where the car is at the beginning. Now we have the second frame where the car is in the middle, so it matches with frame number 2. So this is frame number 2 over here, where the car is in the middle. And lastly, we have when the car is at the end. And when the car is at the end, that matches with frame number 3. So frame number 3 is right here. And when we put them all together, this is what we call a motion diagram. So let me just label this. It's a motion diagram. Right, so each of these individually, this right over here, then this right over here, then this right over here, they were each a frame of this car's overall video motion. When we put them together, we create a motion diagram, and it basically helps us see all in one picture the motion of this car, or the characteristics of this car's straight line motion. So before, when we look at this picture over here, all we know is that this car starts over here and it follows a straight line motion. So the next step we can do to analyze that motion is to break it down into frames. So we have a video first, then we break it down into frames, right? So each of these frames represents a specific moment in time of this car's motion, and they're equal intervals of time apart. Now, once we look at the frames, we can put them all together and come up with a motion diagram. And when we look at a motion diagram, it tells us a lot about the car's motion. We'll talk about that in a second, but I just want you to know that this is what a motion diagram looks like. When we see, it kind of looks like duplicates of an object all in the same picture. So this is how we kind of transfer a video. We transferred a video to a picture through this process, kind of, and we'll be analyzing this in a second, and we'll be talking about how we can use motion diagrams to pull out characteristics of this car's straight line motion. So for those of you who like to think about it as an analogy, we can kind of think of it as stop motion, right? If you've ever seen a stop motion video, it's a bunch of pictures put together, right? So here we're just taking a bunch of pictures and we're overlapping them together to come up with a stop motion-esque type of thing. So all that's important from this slide is for you to know that this right over here is a motion diagram. All right, so now let's talk about examples of motion diagrams. So let me just move this down. Let's move that down. Right, so let's talk about examples of motion diagrams. Let me just write that down. Examples Examples of motion diagrams. So when we talk about examples of motion diagrams, let's, for this example, let's look at a person. We'll just draw this person really quickly. So that's the person we're going to be using for this example. So let's just copy him. Right, so let's look at different types of motion that this person may follow. So let's look at this sidewalk. Let's say this is a sidewalk, and this person starts over here. So starts at the beginning of the sidewalk, then he comes over here, then he comes over here, and then he comes over here. So let's say maybe I didn't draw it that way, but the distance between this frame and this frame is the same as the distance between this frame and this frame. So each of these times, this person, each of these persons I've drawn on the motion diagram have an equal distance between them, right? So that's important to know. This distance is the same. Each of these arrows' length is the same distance. So when we look at a motion diagram like this, where this is frame number 1, let's say this is frame number 2, that we're analyzing, frame number 3, and frame number 4. So if these are equal lengths of time in between each frame, and the person is traveling in the same distance each time, then if you think about it, this person is traveling at a constant speed. So we're going to be talking about what speed means. You might have a meaning in your mind for what the definition of the word speed is, but we're going to be rigorously talking about that later in the course. Oh, I spelled constant wrong. I can't believe that. So constant speed, right? So this person is traveling at a constant speed because we can see that each amount of time he travels the same distance. So for the time it takes to go from this frame to this frame, he's traveling this distance. And in that same amount of time, for the second frame to the third frame, he's traveling the same exact distance. So this is what we call constant speed. Constant basically means same or continuous or equal. Constant means it's not changing. So all this we can read this as this person's speed is not changing. This person is traveling at a constant speed. He's not speeding up or slowing down. But now let's look at a frame when this person maybe decides to go in a different form of motion. So let's look at this person. So this person is always going to start over here. Let's say in the second frame, he's over here. In the third frame, he's over here. In the fourth frame, he's over here. So now let's look at the distance between each of these frames. The distance between, let's label this as frame 1. This is frame 2, frame 3, and this is frame 4. So if we look at it, these are all equal lengths of time. Remember, the distance, the amount of time between frame 1 and frame 2 is the same amount of time between frame 2 and frame 3. So if we look at the distance between frame 1 and frame 2, it's pretty clear that that's a lot shorter than the distance from frame 2 to frame 3. And the distance from frame 2 to frame 3 is a lot shorter than the distance from frame 3 to frame 4. So we can see that this person starts off by moving a small amount of distance with this time, and then in that same amount of time, he moves at a greater distance, and then in that same amount of time, he moves at an even greater distance. So we can see that this person, I'll just put it out to the side, he's speeding up. So this person is speeding up because each amount of equal intervals of time that go by, this person is traveling at a greater and greater distance. So if you think about it, it even looks like this person is speeding up. If you have ever watched a person or a race where a person is speeding up, you can see like they start off slow, then they start accelerating and going away from where they were before at a faster rate. So that's a motion diagram when a person or an object is speeding up. So the last thing we're going to look at, or the last type of example of a motion diagram, let's draw a person there. Let's draw a person here. Let's draw a person here. Then let's draw a person here. So here you can kind of see is kind of the opposite of what I just drew, where the distance, let's label it first, frame number 1, frame number 2, frame number 3, and this is frame number 4. So you can clearly see that the distance between this, the first and second frame, is a lot longer than the distance between the second and third frame, which is a lot longer than the distance between the third and fourth frame. And this, because you can see that remember, the interval of time between frame 1 and frame 2 is the same between frame 2 and frame 3, is the same between frame 3 and frame 4. And we can see here that this person is traveling a lesser and lesser amount of distance with each amount of time. So we can say that this person is slowing down. So if we look at it, it kind of even looks like that this person is slowing down, right? He's starting to travel a large distance, but then he's traveling an even shorter distance and an even shorter distance. So we can say that this person is slowing down. So I'm going to give you an example. So we can say this is constant speed. So this is constant speed. This is speeding up, and this is slowing down. So based on that, I'm going to be giving you an example. All right. So let's draw a basketball hoop, maybe. Let's draw a basketball hoop. Oh, I'm not a basketball player, so I don't really know how a basketball hoop looks like, but I'm going to do my best. So say that's the hoop. We'll say that's the net, and we'll continue it all the way down. So we'll say that's the basketball hoop, all right? And then we're going to draw a basketball. So it's a little bit too big. Let's make it a little bit smaller. Let's say we draw a basketball, all right? So let's say that this basketball, we're going to draw a motion diagram for it. But this is going to be a little bit different. Instead of a straight line, this basketball is going to be actually traveling in projectile motion. All right, so this ball is going to be over here. That's going to be over here. Well, let's just draw one below for good measure. All right, so this is going to be the path that this ball follows. So my question to you is, this is an example. My question to you is this ball, or this basketball, as it goes into the basket, is it traveling at a constant speed? Is it speeding up, or is it slowing down? Pause the video and come up with an answer and unpause it. All right, so just a disclaimer, that was a trick question, and I'll tell you why. So let's draw, so we can see that this ball is moving, right? But if you think about it, this ball is not moving how the person was doing. This ball is not just moving on a straight line horizontally or even a straight line vertically. It's kind of moving in both, right? So this ball is not only going up, but this ball is also traveling right. So this is a technique we're going to be using a lot. I just wanted to give you a sneak peek into it. We're going to have to dissect this diagram into an x direction, or a horizontal direction, and a y direction, or a vertical direction. So for each of these, let's just plot the center of these balls. Let's just use blue. So this is one way we can create a motion diagram, right? So let's map each of these dots to their respective axis. So if we look here, this blue line aligns here, the next blue line aligns here, the next one aligns here, and the next one aligns here. So you can kind of see that these are equal distances apart. But now let's look at the vertical direction. So if we map it, we get here, then we get here, and then we get here. So you can see that this is a lot of distance from the first frame to the second frame, but then it gets to a smaller distance and then a smaller distance. So you can see, if we kind of map it out here, we can see on the x direction, because they're equal frames, it's traveling at a constant speed, right? So you can see the basketball, if we're looking only at how it's traveling to the right, it's traveling at a constant speed. But if we look at how it's traveling up, we can see the lines get a shorter and shorter distance from each other as time continues. So we can say as it travels up, this ball is slowing down, right? So as it goes from here to here in this direction, as it travels to the right, it's maintaining the same amount of distance between each frame. But as it goes up, there's a lot of distance from here to here, then there's a smaller distance, and there's a smaller distance. Now, one important thing to understand is this ball is not slowing down the entire time. It slows down up until it gets here. When the ball goes from here to here, you can see that it's speeding up. So this ball is speeding up when it gets from the top as it starts going down. And we'll talk about why it starts speeding up so this is projectile motion, just to be clear. So this might be a little bit complex, but I just wanted to give you a sneak peek into motion diagrams for vertical and horizontal. And we'll be talking about why it's speeding up over here and why it's slowing down until it gets to the top and why it starts speeding up. If you've ever thrown an object in the air, this is exactly the type of motion you'll find. Like the object will travel up and it'll slow down, and then as it starts coming down, it'll speed up. And if you ever throw in an object horizontally, this might not be as easy to understand, but it's important to know that actually when you throw an object horizontally or even up at an angle, the horizontal distance between each frame will be the same. So the ball always travels at a constant speed horizontally, and it'll be slowing down and speeding up as it gets to the top. And if you didn't really understand what that was about, like I said, don't worry. We'll have a bunch of videos just talking about, like I said, what this is called is projectile motion. This is projectile motion.